thank you everybody for staying to the very end of the conference. I am honored to be the last speaker, and I'm going to take that opportunity to stretch the science a little bit at the very end. So let's start with the rigorous science and then move on. I ran out of business cards, so please write down my email address. Would be a good idea in case you want to follow up. And I want to start, I guess, with a general introduction about the kind of water I've been working with. I will try to enunciate clearly for the non-English speaking people in the group. And I first want to introduce this special water, which I was here last year with my colleague Lee Lorenzen. And oh, right, I have to use this. And before I even start with the details of that special kind of water that we use, I want to just give an overview, a philosophical overview of the approach I'm taking here in this lecture. So I'm going to talk about digital molecular information generated using Benveniste's technique. And then I'm going to talk about frequency information generated from a signal generator in an attempt to be rigorous and scientific about this phenomena of imprinting water with information. Then I'm going to discuss a technique that I've developed, what I call resonance frequency conductivity measurements, which is similar but different to Serge's technique, because it does involve electrical impedance spectroscopy. And then I'm going to discuss the data in terms of different types of energies used to transfer information into the water, different types of water used to store the information, and in an attempt to look at the science behind the phenomena of imprinting. Seems a lot of commercial people out there use this process, and there's relatively little science to investigate the phenomena. So, as an example of the different types of energy carriers that I am interested in, we have a list here, and I've so far researched most of these different kinds of energies. I've started to, well, I don't know if you can see that, but I can't, so that's pretty useless. I'm colorblind, so what's this, yellow on white? I guess that doesn't register in my eyes. Sorry, so I won't use that. I've used all of these different kinds of energy patterns, except light and sound so far. I do intend to extend this repertoire of energy carriers. I have used plasma devices, particularly a device called the Therify, which uses counter-rotating plasma waves opposing. But I do not have the data yet. I'm still in the middle of collecting that data. Okay, so let's start with the water itself that I've been working with. This is water that has a patent, actually 3 patents behind it. And the basic process involves treating steam, which is enhanced with minerals and silica, with a very strong magnetic field. Oh, you think this will be better, huh? I can't see that any better than the other one. In fact, it doesn't even have. Well, nice try. Doesn't work. Okay. Anyway, so unlike the water in the bridge water that we heard about earlier in this conference, this water is treated with a very strong magnetic field to the tune of 20,000 Gauss, and in addition to 2 different wavelengths of light. And what's particularly unusual about this treatment is that it's done sequentially and in a cyclical manner. So it's not just one treatment of each kind of energy field, but it's a cyclical process that lasts for 24 hours. And after that process, the water is altered and has some unusual properties. One is that it has an unusual O17 NMR spectroscopy. And don't ask me why my colleague Lee Lorenzen decided to use O17 NMR. It's a little unconventional, but apparently in an attempt to characterize Lourdes' healing waters, in an attempt to heal his sick wife, he used this particular kind of spectroscopy and noticed that Lourdes, as well as several other natural healing springs on the planet, have a characteristic signature at 65 hertz, in contrast to ordinary spring water, which it has a peak at 120 hertz. So that's one of the characteristics. And as a result of this strong magnetic field treatment, this signature lasts for 2 years, which is quite a long time. In addition, there's altered Raman spectroscopy data, and you can see the lowest green, I guess, colorblind, on the bottom is the Vivo water, for those people in the back who cannot see it. So there is a characteristic change in the Raman spectra. So my particular interest was to look at the electrical properties of this water using my technique. But before I go over that, I just wanted a quick overview of the kind of water for those medical doctors and practitioners in the audience, that this water has been studied clinically. There was an extensive study with 300 diabetic patients in 5 hospitals in China, and they measured lower blood glucose, increased intracellular water content, increased basal metabolism rate, and increased phase angle. Phase angle is an obscure bioelectric impedance measurement that most people don't know about, but it correlates with physiological changes in health in general. And in most cases, phase angle decreases as a function of age and disease, but after drinking this water, it increases. Okay, now other clinical studies have been done showing, just to summarize, enhanced wound healing, increased stamina, another study on glucose metabolism in diabetics, improved immune function, and recovery from injury. So by now there have been quite a few clinical studies, and clearly this water does not behave like ordinary water, so that would be a logical water to study further. Now, not only does it affect humans, but affects animals. Here's an example of a couple of racehorses that were over the hill, and they were not feeling well for several days. They drank the water. 3 days after drinking the water, not only were they better, but the owner decided, well, they were good enough to put them back in the race. And these 2 horses won first and second place. Now, what are the odds of that, right? So clearly, animals love this water. They benefit by it. If you give this to dogs, they will only drink the Vivo water. They won't drink mineral waters right next to it. And it's good for plants. Here's some studies. So in other words, all biological systems seem to benefit from this water. Here's a study that we did with hemp, and after 3 weeks of, 8 weeks of growth in this water, the biomass increased by about 50%, and the nutrient content increased by about 30%. That is to say, the CBD content was increased by about 30%. So clearly, all biological systems seem to like this water. So there's my biology side of the story. Now we're going to switch to electrical measurements. So let's start with this whole concept of molecular information, a la Benveniste. Now, these days, most people just transfer the information from a molecule into water with a laser beam, a la Gariev and Luc Montagnier, and many people in this audience use ordinary electromagnetic fields to facilitate the transfer of information from the molecule. Now, what Benveniste did, which was rather unique, was to store the information in a computer and then play it back, and has the same biological effect as the molecules. And we all know Jacques' work, but I wanted to make a distinction between these 2 different types of information transfer. And he called it digital biology, and our Russian colleagues here have coined the term informational pharmacology, which personally I love because I have a background in pharmacology, and this is great. Okay, so when we talk about molecular information, what are we talking about? Well, there's the 3D charge distribution around a chemical molecule. Of course, there's information and oscillations of the chemical bonds that make up the molecule. And there's electrical information and there's quantum information. So if you look at the field of quantum chemistry, you can see the diagram on the right, which is a map of the contour maps around the molecule. The molecule is this old stick model that Lionel was so attached to in his earlier speech during the conference. Well, you turn it on its side, and then you can see the molecule. God, I can't even see white on black. Oh well, never mind. You try. You think so, huh? Well, not that button, not that button. What? Right. There, that thing is the molecule in the middle. Yep. 2 down, 1 to go. And you can see that the field, the matter field, if you will, around the molecule can be demonstrated visually. And this is the kind of field that we're talking about. And as I said before, most contemporary researchers just transfer the whole thing into water. But Jacques, of course, tried to actually measure it and store it. Okay, so the digital imprints that Benveniste made were done by my colleague, Dr. Fabrio, in the National University of Mexico City. And here I'm going to present some data done with 2 particular molecules that were imprinted using Benveniste's technology, which was actually transferred to him before he passed. And I don't know how much of this is proprietary, but this is the methodology that Dr. Cabrillo used. Now, quercetin is a molecule from a plant called Pholium guava, and it is known to have spasmolytic activity, which means it inhibits smooth muscle contraction. And the study that was done using an in vitro model system, and we actually measured the amount of quercetin using HPLC to quantify the effects. Okay, so digital quercetin was generated, the digital imprint of quercetin was generated using Benveniste's method. The signal was stored in a computer using a proprietary file format. The signal from the computer was transferred to an audiophile amplifier, rather. The amplifier, the signal then went to a Helmholtz coil, which generates a standard classical electromagnetic field. And after treating vivo water for 1 hour with this field, we measured a variety of different effects. The first effect here is this ability to inhibit guinea pig ileum smooth muscle contraction. This is a standard pharmacological assay for measuring the effects of drugs that inhibit muscle contraction. Muscle contraction is induced with an electric stimulation of 42 volts under these parameters, and you can actually visualize the peaks that are generated from the electric field induced contractions, and they can be seen in this next graph. And in the absence of any stimulus, you get a peak height of about 5 centimeters, and then after you treat this with a conventional herbal extract that contains quercetin, you get about a 50% inhibition of the muscle contraction, which you'd expect. Nothing new there. But the conventional extract contains quercetin, so you're not surprised that this molecule would inhibit muscle contraction. But the digital imprint of quercetin also produced an effect is not quite as strong, about half as strong as the chemical itself, where, no, again, there is no quercetin chemical present in this water. And in order to observe this effect, you have to repeat the process 3 times rather than once with the chemical. So it's significantly less powerful than the chemical, but nonetheless, there is an effect. Okay, now the next experiment is with water treated with morphine. Now, this water, the digital imprint of morphine, this water was given to mice, and they loved it almost as much as they loved this alcohol. But the point being that the behavioral changes that they made were very similar to drinking alcohol. They were staggering all over the place. And I couldn't really find a picture of a staggering mice, so this is what you got. Okay, and what's even more interesting is that that effect, behavioral effect, was inhibited by naloxone, which is an opioid antagonist, which indicates that the information in the water was working in their bodies via the opioid system. And even though there's no chemical present, the body seemed to think there were these chemicals, and they were inhibited by the standard opioid antagonist. Okay, so now we're going to move on to some conductivity measures, again using the digital morphine signal transferred to water via a standard electromagnetic field. Now, I want to mention a little bit about the technique that I use, since it's different than Serge's technique, and as I call this, what I call it. And here we go. So the first thing you have to know is that standard conductivity meters measure conductivity at a fixed frequency of approximately 2 kilohertz, which is an arbitrary frequency electrical engineers came up with. And my methodology involves using a Gamry electrical impedance spectroscope, no light, spectroscopy, which allows me to adjust the frequency that I take the measurement. And the point being here is that just intuitively, I feel that when taking a measurement of a system, an electrical measurement, you have to take your measurement at a resonance frequency of the target. In this case, it's water. So what I actually do is the machine measures, measures, I'm trying to find the pointer, measures resistance in kiloohms, and which I present the data in terms of conductivity, just so people can relate to conductivity more than resistance. Maybe, maybe not. And anyway, the point is that the frequency that I use to take these measurements is 42.7 kilohertz, which is the resonance frequency of water used in ultrasonic electrolysis to really blow water molecules apart, and was used by Keeley to implode water. So 42.7 kilohertz is kind of a magic frequency that really resonates with water, and that's the frequency that I take my measurements at. Okay, in addition, I do some other unconventional things because that's what I do. Anyway, I use very low combination of AC and DC voltages in the order of 30 millivolts, which is about 3 times less than that Serge uses. I don't use cylindrical electrodes like Serge uses. I use flat counter-wound Tesla coils as electrodes. I use very closely spaced electrodes, and I used electrodes made of dissimilar metals, silver and gold. So all 4 of these parameters make it very different than the standard method that Serge uses. Now, dissimilar metals are quite interesting because in the scientific literature, in these 2 references that I've, 3 references that I have here in physics journals, nonetheless, they talk about the the fields, the unconventional fields that are generated between electrodes made of two dissimilar metals. They draw analogies between this field and the Casimir force and describe the phenomena of electron tunneling which exists between electrodes made of these special kind of dissimilar electrodes. So the combination of these four factors seem to, I believe, increase the sensitivity of the method. Okay, so that's the method. In the experimental data that I'm going to present, as I said, the measurements are made of a resistance or resistivity in kiloohms, which I just conveniently convert to conductivity. For each data point, I'm using at least 3 measurements, and I take the average, and the standard deviation, it varies between 3 and 7%. And therefore, I have not included error bars in each of my points because that's the variation. Baseline varies according to the mineral content of the water. So each different water has a different baseline, and therefore the data is presented as a percent change relative to untreated control. Okay. Now, here we're using digital morphine, as I said, delivered to the water using a classical electromagnetic field. And these are the kind of data you get. Here's the overall effect. Now, this is actually the raw data. This is the one graph that actually has the raw data to do the statistics. And you can see there's about a 26% change with a statistically significant effect. Now, that's decrease in resistivity or an increase in conductivity. So from here on in, I'll be showing conductivity data, a la this graph. And again, the percent change. So the first thing I decided to look for was different kinds of waters. And in fact, different waters behave very differently. And as disappointed as I was, Vivo water here on the far right did not perform the best. Distilled water works best, and I wonder if it has to do with the lack of structuring or with the lack of minerals present in distilled water. Further research will be required for that. Okay, now here's the how long does the effect last after you turn it off? And in this particular case, for the first 2 days, the effect increases a little bit, and then it drops, and by 14 days, it's gone. How long do you have to treat the water? Well, in this case, the optimal treatment is about an hour and a half. Okay, now I was interested in studying the effects of different geometric patterns on the phenomena of imprinting. These 2 geometric patterns were chosen, and the geometric patterns were placed between the field, the generator, and the water itself. These are just 2 patterns I had floating around the lab. I'm not particularly biased, although the one on the right is a hexagon, and there's some evidence that Vivo water is hexagonal in nature. So here's the effects. In both cases, the treated water with the geometric fields was inhibited compared to the control. I mean, the purpose of doing all these experiments was to see if I could enhance the effect. I would like to use this process for commercialization, and I want to find the strongest method of imprinting water. Well, adding geometric patterns, or these 2 geometric patterns, does not seem to help the situation. Okay, so that was the experiments I did with that kind of digital signal. Now I'm switching to, again, I'm trying to be more scientific about it, so let's go to a signal generator and use square waves generated from this kind of a setup. Signal generator, amplifier. Now, you can see here that on the bottom I use a toroid, and when there is a geometric pattern, that's where it would be, and then I'm using an electric field. Now, this is a kind of an unconventional way to stimulate or imprint water, but this is the method that seems to work quite well. And so now I have to tell you a little bit about a toroid and the kind of non-classical electromagnetic fields generated from a toroid. A solenoid, as everyone knows, would generate a classical force field, classical electromagnetic field. But when you take that solenoid and wrap it around itself and form a toroid, you generate a very non-classical field. It's not even considered a force field. It's a potential field. The other fancy name that physicists give it, it's as an SU2 gauge field, and audience might be more familiar with the A field as distinct from the B field. And there are many different kinds of coils. These are two different geometry coils that have been used. These kind of coils are called self-canceling coils. In the one on the left, which is a toroid, the classical electromagnetic field is trapped on the inside, and the A field is emitted from the outside. But in a counter-rotating coil, the electromagnetic field is canceled, and the field that's generated from the outside is also a non-classical electromagnetic field. Okay, so these are the kind of coils that I use, a little unconventional, but you should know that in the physics literature, these kind of non-classical electromagnetic fields are described. And they're described as non-Maxwellian, non-Hertzian, non-Abelian, and they don't know what to do with these fields, so they describe them as terms of what they are not. Okay, biologists would never do that. Maybe, maybe not. Okay, so when I say non-Maxwellian, they have properties that do not obey the classical Maxwell's equations. One of those properties is they travel faster than the speed of light. And here's an example of a shape of such a field. This is a field that Beltrami describes in the literature. Anyway, the point is that this stuff is all in the physics literature. Now, I was talking about self-canceling coils. Here's a visualization of some of them. The kind that I use is the caduceus coil in the upper left, and the bifilar coil in the middle, and the counterwound coils on the right, lower right. In the bifilar coil, you probably can't, in the back, you can't see those two arrows. The current flows in opposite directions and cancels. And that generates this non-classical field. Okay, so there's your moment to, not finished with the education yet. Okay, so yes, so here's an article that was published almost 20 years ago, looking at the mathematics of the gauge fields generated by a toroid. And what they concluded was, in fact, a toroid generates two A fields of opposite polarity and different phase. And here's the geometry of the two A fields generated from a toroid. So the point is, okay, good. The point is that there's a lot of science behind these kind of fields. They're pretty obscure, and nobody in the bioelectromagnetics community uses these fields, although I have presented this data to them. And they kind of scratch their head and they go, why would you do that? And one of the reasons for doing that is these fields have biological effects, even more so than a conventional electromagnetic field. But at least I want to show you some data that I collected, putting a complex waveform into a signal generator, into an amplifier, into a this was actually done with a caduceus coil, not with a toroid. And you can see that I measured lymphocyte proliferation with lymphocytes grown in tissue culture using standard technology, and measured the growth using tritiated thymidine incorporation into DNA. That's my biochemistry background coming into play, standard biochemical assay. And you can see that the first peak on the EMF field is similar to the strength of the effect produced by interleukin-1. So in other words, it's a very strong mitogen, stimulates the growth of these cells. Okay, that's just to make the point that, oh, sorry, this is water treated with this particular complex electromagnetic field and then given to the cells in culture. So we are able to observe biological effects. And that's another whole lecture. I've done a lot of experiments with these kind of fields, but I just wanted to make the point that the reason for using these is they're biologically relevant. Okay, now let's go back to measuring the conductivity. And from here on in, we're not going to use a digital signal of morphine. We're going to use a signal generator generating square waves at 42.7 kilohertz. Again, and the output, the power output is about 20 watts from a standard amplifier, audio amplifier. Okay, and again, the same thing applies. The measures are in kiloohms and converted and then calculated as the percent change, like I said before. Okay, so here is the overall effect. Now we're talking conductivity. And after 1 hour of treatment, in this case, there was a 24% effect. And 24 hours later, the effect already is inhibited by half. And it's already starting to lose the effect. There's their number, their raw data with statistical significance at 0.02 level. Okay, so now the first question was, how reproducible is this phenomenon? Because someone's going to ask me that. So here's the same exact experiment done 3, 4, 5, 6, on 7 days in a row. And the magnitude of the effect varies enormously. In fact, sometimes you don't see the effect at all, and sometimes you get a nice robust effect, like on day 6. And God knows what was going on in the environment that, phases of the moon or God knows what, that causes this variation. But it is highly variable. Now, my next question was, what was the effect of different types of water? And in this case, Vivo water on the far left was significantly less than Niagara water and commercial water called Vata, which I suspect, well, Niagara water is the cheapest water you can buy on the market. It probably has no minerals at all, or very little. I should do a mineral analysis to compare, but you can see some waters work very, very well, like Niagara, and other waters like this Epura water don't work at all, and everything in between. Imagine that. Okay, so now the question was, well, what happens if you combine the electric field versus the toroid? In combination, in this particular experiment, they caused a 33% increase. If you combine them, if you use them individually, they're far less effective, but in combination, they're significantly more effective. Hence, I use this combination of electric field and toroid for all subsequent experiments. Okay, now the question was, well, the toroid, as you now know, is one of many different self-canceling coils. What happens if you use a bifilar coil? Well, didn't work as well. And this bifilar coil down here, well, I'll press the button if you can see it better than me. This bifilar coil, that didn't work, did not work very well. So depending on how the coils are wound, they can make a big difference. And the caduceus coil was also less effective than the toroid. So I used the toroid. Okay, now the question was, what about electric field versus magnetic field? Again, in the presence of a toroid, the magnetic field seems to work significantly less, and I cannot explain this. Any contributions about why this would be, I don't know. Now, I decided to add some chemical additives. Now, remember, the goal is to find what additional things you could do to the water to enhance the effect. So I'm thinking, well, let's add silica. Okay, that's the magic ingredient. Everyone seems to think that improves the situation. Well, I used several different concentrations of silica, and it inhibited the effect. It's still possible. I'm using too much silica, so I'll have to repeat these experiments using less and less silica. Now, in this case, the case of alcohol, I used 20% alcohol because I was told that's what homeopathic remedies use. So if this is supposed to stabilize a homeopathic remedy, it does not facilitate the transfer of frequency information into water. Again, I haven't done a whole dose-response curve. Okay, and the last experiment is the effect of on resonance versus off resonance. Remember I said 42.7 kilohertz was a resonance frequency of water. Well, what happens if I do the same experiment but I do 42.0 hertz, which should be far enough off the resonance frequency to produce a non-resonance effect? And what I saw was a significant reduction in the ability of the information to get transferred into the water. Now, I'm making a big assumption here. I'm assuming that the conductivity measurements that I'm taking is a measure of the ability to imprint. We could discuss that, but that's my assumption. Okay, so in conclusion, Vivo water has a characteristic NMR signature, beneficial to the body, etc. Digital imprints of quercetin inhibit muscle contraction in vitro. Frequency imprints at 42.7 kilohertz increase conductivity in general. The frequency lasts for anywhere between 1 and 3 weeks, depending on the kind of energy and the kind of water you use. The combination of transverse and longitudinal waves work best. And chemical stabilizers used in homeopathy inhibit the process. Okay, so that's in essence of my talk. Now, in closing, I want to address one more kind of energy carrier that I have not mentioned before, and that's right at the bottom, conscious intention. Now, this is kind of alternative, and I just did a few experiments just to see what would happen. I had a healer come in to the lab, and she waved her hands over the water, and I measured the conductivity changes immediately after. And what takes an electromagnetic field 12 hours to produce a 30% increase in conductivity took this particular person less than 60 seconds to produce the same effect. So just for the record, it is measurable and quantitatable, and it seems to work quite well. Here's my collaborators. Thank you very much for your time and your attention.
Thank you very much, Glenn. Your last conclusion is really fantastic, mind-blowing.
Thank you.
Are there any questions?
Thank you, Glenn. Very exciting talk. I'm sitting with a little bit of frustration, not from your talk, but in general, that we are all discussing these types of affecting water in different ways. And in some way we feel that we're comparing apples and oranges. But on top of that, we are also using measurements that are also very different. And now you invented your own. And what are your thoughts on that? I mean, if we don't have the same baseline, it's going to be so hard to compare.
So that's a great question. My answer is that all these measurements are relative to the untreated control. So I'm after an effect, and I'm looking at these variables and how they influence that effect. Now, the fact that everyone uses a different method is not particularly beneficial. That's true. I saw at least one slide somewhere in the last 4 days where the conductivity measurement, and I don't remember what the other measurement was, it did not correlate. So there was an effect by one measurement and not by another. So, you know, exactly how the water is changed after you imprint it, what specific structural changes, electrical changes, optical changes. I mean, we're opening Pandora's box here by first initially observing these changes and then trying to ask some scientific questions. So I totally agree. I mean, you know, we have so many different methods, and if we can do some kind of a consensus, it would be great if everybody used the same method, but we don't.
Glenn, many thanks for excellent presentation. I mean, this idea with electrode, I mean, we will test it anyway. That's it's nice. Another, and I see many correlation with our own research. I mean, it's nice to see the two laboratories. They receive similar results. Yeah. The question is, why are you using only one frequency? I mean, you can perform a kind of characterization over time and over different frequency, and to give to receive a kind of real characterization of impact.
Yes.
And then you can see more or less really distinguish between your digital morphine and digital whatever. I mean, why not do this for measurements?
The reason I only use one frequency is because I'm trying to make the system simple. I'm trying to be scientific, and I'm trying to initially characterize the system, you know, in terms of conductivity measurements. And then, of course, future research, I can compare. I mean, there's so many variables, as you can see. Changing the frequency, you know, okay, that's another variable. When I come back next time, I'll have more data.
Yes, in one of the slides that you showed a graph of effect versus time, exposure of time, right?
Treatment time.
And so the time went up to a peak of 90 minutes,
Right.
and it seemed to, after more exposure, decrease back
Yes.
toward zero.
Right.
To what do you attribute that?
Saturation. If you, and I've seen this many times with different kinds of energies, there's an optimal window of treatment. Like most things, there are windows, and if you treat for too long, you inhibit. Now, why does the conductivity go down instead of back? That's up to the theoretical people in the audience. But yes, that is an important observation.
One thing, the reason I noticed that particularly is that we've seen the same effect with imprintation on quartz.
Ah, great. Well, thank you for confirming those results.
Okay. More questions?
Thank you very much for a most interesting presentation. Just a little historical note here. I have a paper that comments that the A field, the magnetic vector potential, was killed in a meeting in the UK in 1880 in a dispute between scientists and engineers. Going on to the time I did my undergraduate physics, it was treated as a bit of a mathematical trick. But of course, there are papers showing a biological manifestation, and also even engineering patents for communications using this. And yet, when you talk to the average engineer, they don't really seem to discuss it.
Well, there are numerous publications, so all I can do is show you.
Yeah.
But yes, thank you for the historical perspective.
Okay.
Well, thank you very much for this interesting presentation. You're presenting many effects in terms of conductivity change and many different causes. Well, do you have any hypotheses about the mechanism that will link this cause and effect? Because without it, well, how do we know that the cause is actually the real cause for the measured effect?
Well, you know, in this audience, there are two kinds of people, scientists here, experimentalists and theoreticians. I'm afraid I'm the former, and I mean, I could speculate about the mechanism, but I don't really know.
Any more? No. Then I'm afraid we have come to the end of this. Thank you very much.